Welcome everyone. I believe we have customers from all over joining us today throughout 3D Vision, Computer-Aided Technologies, and MCAD. So thank you everyone for joining us. My name is Casey Gruden. I am the account manager in Cleveland, Ohio, and today we will be covering the simulation solutions. Robert Warren is our simulation specialist, and he will be demonstrating the capabilities of our simulation packages so that you can determine which package would best fit your needs. Whether you're new to SOLIDWORKS or if you're a longtime user, simulation is a very powerful tool that you can start using today to get more out of your CAD models. So much of your CAD investment goes into the engineering to create your library of models. So once you have this large investment in CAD models, what more can you do with it? How can you leverage these models further and maximize your investment? You already did the work, you spent the time creating these intelligent models. Now let's take a look at what else you can do with them. Robert will be demonstrating these benefits today, and as you may have heard, SOLIDWORKS is promoting simulation this month, so stick around until the end and I will cover the end of quarter incentives that are available in June. If you have questions, please type them into the comments box and we will address them at the end. Robert?
All right, thank you, Casey. So like Casey said, we really wanted to present this to kind of see which simulation is right for you. So before we get into the nitty-gritty, I just wanted to kind of cover what SOLIDWORKS simulation is. And it's really a tool in your toolbox that leverages the power of SOLIDWORKS, that takes an infinite problem and basically breaks it down into small problems that allows a computer to solve it. I did want to cover a little bit about the SOLIDWORKS simulation packaging here, all the way from SOLIDWORKS Premium through Simulation Premium.
So what type of simulation is available in SOLIDWORKS CAD packages?
So SOLIDWORKS Premium offers linear static analysis on parts and assemblies and a kinematics package called Simulation Motion.
Okay, so the remaining simulation standard, professional, and premium are standalone packages that run right inside of SOLIDWORKS.
Yes, that's exactly right. And that's where I'm going to focus most of my time today in covering some of those modules. So as we get into it, I had a couple sections that we wanted to go through, and I just want to talk a little bit about the initial design analysis, do some weight reduction, talk about how long it's going to last, fatigue analysis, some optimization, and some of the nonlinear and high-end simulation premium capabilities. So the first model that I want to look at is this kind of trunnion components, 2 cast arms, some pins, and what I'm going to do is just put a 5,000 pound load on this, pull upwards on it, hold it on either side, and we really want to see, keep our stress below a certain value and our factor of safety 2.0 or higher. So let's go ahead and jump into SOLIDWORKS and take a look at this.
So is this an actual SOLIDWORKS model?
Yeah, actually it is, and that's one of the benefits of using simulation is you're right inside the SOLIDWORKS interface. So what you see here is across the top, as soon as you add in simulation, you get another tab on your command manager, or like I like to call it, the super toolbar. You have access to creating a new study, and what you see in the drop down here is basically all of the study types that you would get if you had Simulation Premium. Well, I'm going to be just using for this first study a base feature, so I'm just going to call it 5K. Usually I use it per my loading condition. I name that. But the static linear analysis, this is actually part of SOLIDWORKS Premium. What you're going to see is it actually generates a new study for me, gives me a tab down here, just like another workbook in Excel or another sheet in a workbook in Excel. One of the benefits is my materials came over. This was generated in SOLIDWORKS just like Casey had asked, and my materials were assigned as I was designing the model. They're going to carry over inside a simulation. Next step is I just need to tell the software, how am I holding this? Where are my loads? So we have a wide variety of fixtures that we can assign. In this case, I'm just allowing it to rotate about these 2 pins on the end. I'm also going to assign a force, but we could also do a torque, pressure, gravity, multiple different loading types as well. And in this case, I want it to be in an upward direction, so I'm going to give it a reference, which is the top plane. And I'm going to specify here that I want this to be 5,000 pounds. So we have our force, we have our fixture. I'm actually just going to hide these out of the window. We're going to mesh it or discretize it or break it up into those smaller problems. Because we're inside of SOLIDWORKS, simulation understands the size and the geometry and gives us a good resolution of the mesh right from the very beginning. At this point, I'm going to run the software and we'll take a look at the results once it finishes.
So is that a pre-ran study?
No, that was not pre-ran. I just ran that live. I like doing that because it shows the speed of our solver. And it's actually really quick. One of the things that also happens with simulation is we can animate this. One of the things that I like about this, it is an exaggerated scale. It's 452 times. That's on purpose. It gives me a good feel for, is my force in the right direction? Is it moving how I would expect it to move? We can certainly take this back to a 1-to-1 scale if we want to. So I can switch it to a true scale, but we also have different options in here where we can look at the principal stress if we need to, or let's say a normal stress in the Y. We were looking at von Mises, so we'll go ahead and go back to that. Also notice that this push pin, that's a carryover from SOLIDWORKS. Because we're inside the interface, we can hold these property managers open. I can also change things like chart options, show where my maximum value is, it picks that out, where my minimum values for stress are. So it gives us a lot of feedback right in the interface of what we're looking at with regards to this. So I'm right around 11,000 PSI, so we're looking pretty good. We're below our value that we needed. We can also look at displacement. So again, this is exaggerated, but we're only at 0.09 millimeters displacement. We could switch that to inches, but maybe displacement is the criteria. Stress isn't necessarily a factor. We could also look then at factor of safety, and this is a big portion of what we're looking for. We wanted it to be 2.0 or higher, and what we can see is the reason it's all red is because that's the lowest factor of safety, and we're at 3.2. So again, we're meeting and exceeding those values. One of the things, though, that I want to kind of back up and show you here is all of the plot options that we have. So a lot of times, I did strain gauge testing when I was in industry, and you had a strain gauge that was on the surface of the geometry. You didn't really know how far in is the stress penetrating the arm. Did I put my strain gauge in the correct location? The section clipping gives me the ability to look essentially like an MRI into the model and see how far is that stress penetrating in. One of the other options that we have is I can do ISO clipping. So we can highlight very quickly, even if this is a simple assembly, but if it was a very large assembly, it allows you to see exactly where the high stresses are in that model, and it highlights those quickly and effectively. So what do we see? We're right around 11,000 PSI. It was a very quick solve. We got that feedback pretty fast and intuitively, and we had a factor of safety of 3.22.
Okay, so it looks like this meets the factor of safety, but SOLIDWORKS is actually telling us that it exceeds it, so it could be over-designed.
Yeah, that's exactly right. So if our factor of safety requirement's 2, which is a typical factor of safety requirement, we're essentially over-designed because we're at 3.22. So that's the next step is, where can we take weight out of this manually but still keep it as strong? So we always want to reduce weight, kind of take material cost out of the analysis. So right now it's at 36 pounds. I can run the mass properties on this, but you can trust me, it's 36 pounds. We have the same stress in factor of safety requirement. So one of the benefits, again, because we're right inside of SOLIDWORKS, is I actually made a configuration already that has holes cut through this. But before we even get there, I want to cover a plot that I purposely left out from the previous run, and that's called the Design Insight plot. And what the Design Insight plot does is it shows us where the structure takes the energy of the load. So because we're pulling up on this with 5,000 pounds, that energy has to be dissipated somewhere in the structure. That's where it's blue, or it has this dark blue coloring. Anywhere that is clear, we can actually remove geometry out of those areas. So the indicator for me is I've got these solid pins on these ends. I can remove material out of those, and that's the configuration that I made. So instead of having to switch to that configuration, generate a whole new study, put all these different things back in, which actually wasn't that bad in the first place, I can actually copy the study. This makes and allows me to reuse that geometry. I'm going to just call this 5K WR for weight reduction, not %K. And what I'm going to do is I'm going to switch to my weight reduction configuration. And that quickly, it generates a study, and what it does is I can switch my configuration. I have the holes through my pins, and my materials carried over, my hinges carried over, my force carried over. What I need to do now is just simply remesh and then rerun the analysis. So I'm going to go ahead and mesh it again. Again, SOLIDWORKS, because we're right inside of here, understands that the geometry changed and meshed it appropriately. There's no exporting this model out, coming back to SOLIDWORKS, making the changes, and exporting it out again. So what are we seeing here? Right around 11,200 PSI again. My factor of safety looks right about the same. If I look at my design insight plot, what you're going to see with this is we remove the weight in an area, or we remove material in an area that wasn't affected by the structure or the structural or structurally intense. So we were able to kind of keep those same values as far as our stress, our strain, and our displacement factor of safety, but we just removed a bunch of weight out of this product. So if we come up here to my Evaluate tab, we go into Mass Properties, we went from 36 pounds to 26 pounds. We just reduced 10 pounds out of this product that quickly just by looking at a couple plots that come in standard simulation. So again, 11,200 PSI, same factor of safety in a weight of 26 pounds. So we're looking pretty good in the design.
So Robert, before you move forward, everything you just showed so far is included in SOLIDWORKS Premium and Simulation Standard, is that correct?
Yes, so if you have SOLIDWORKS Premium right now, you have access to everything that I've just shown you. Or if you have Simulation Standard and SOLIDWORKS Professional, you have access to everything that I just showed you. What I'm going to move forward on and look at is fatigue. So how long is this design going to last? And that is specific to Simulation Standard. So we need to make sure that this survives a certain amount of loading. And not only are we going to pull up on it with 5,000 pounds, but we're going to push down on it with 5,000 pounds as well. And this is a fatigue study. So when I go back up to my simulation, I start a new study. We would choose fatigue at this point, so this guy right here. And we have a couple different options for fatigue. We can do a constant amplitude fatigue. We can do a variable amplitude fatigue. We can also bring in sinusoidal loading or harmonic loading and random vibration if you have the higher Simulation Premium package. So we're going to switch to the fatigue study. A couple additional things that need to be added with regards to a fatigue study, and one of those is a stress to number of cycles curve. This data can actually be found by using materiality, which I'll show you here in a little bit, or Atlas of Fatigue Curves. There's many other sources for this, and a lot of the materials in the SOLIDWORKS database actually have this already. The next step is we want to go in and take and add an event to this. So I'm going to edit the definition. I have a 500,000 cycle, 5,000 pound load, and we're going to put this on, so we're going to pull up on it and we're going to push down on it with regards to that. I'm going to go ahead and run this fatigue analysis. It's going to go back, look at the study, and it's going to tell us we have about 77% damage because of that, and my life expectancy is actually right around 649,000. So fatigue can really be used in two ways. One is you have a certain warranty that you're claiming. This part's going to last 5 years, maybe 10 years. You need to make sure that it's going to last that number of years or cycles. That's where fatigue comes into play. The other aspect is you can actually do kind of planned obsolescence. You could work it the other way. You know, you want to make sure that, you know, XYZ component's going to last 3 years, your warranty is for 2.5, so the customer feels good, it lasted beyond what the warranty was, but they're still going to have to buy another one coming up down the road. So depends on how you want to use it, but fatigue is a good module to have. The other thing that it does is we don't have to do one event. We can do multiple. So if this was heated up and cooled down at a different rate than that force being applied to it, or it had a torque applied to it as well, you can do multiple events and combine loading for fatigue, and that really gives you the ability to have an understanding of how this really is going to last in the real world. So right around 650,000 cycles. So we're looking pretty good. We want to move on to the next step, which is really optimizing the design.
So fatigue is included in Simulation Standard and Simulation Professional, correct?
Yes, that is correct. So optimization is one of the additional modules that's part of Simulation Professional. There's a bunch others, frequency analysis, thermal analysis, pressure vessel analysis, but optimization is the one that I see is the most beneficial. So what I'm going to do is switch to a design study. And in this design study, you're going to notice that we have optimization as a checkbox. Design studies are standard inside of SOLIDWORKS, so you can actually use these to kind of optimize a design based on criteria for just shape, volume, things like that. In this case, though, what I did was I told the software, I don't want to adjust the radius on this arm, and I also want to adjust the thickness of the arm, and I gave it a range to work within. I also told the software that we have constraints for stress, and I want it to be less than 25,000 psi. That's always been our goal. And then I want to minimize mass. The less weight we have here, the less raw material, the better our savings are cost-wise, but I want to keep my strength the same. And when I'm going to say run here, what you're going to see is it's going to actually run through several scenarios. So it's basically picking the maximums of the range, the minimums of the range. It's going to run the initial, and as it steps through this, you're actually going to see that the different options change. So we do have a question that says, can you change one of the constraints to a roller slider type?
I think that was earlier.
Oh, okay.
We can go back to those.
Okay, yeah, we can go back to those. Yep, not a problem. So what you see here is anything in the gray is it's going to go to, basically as a possibility it's going to work. With regards to the pink is actually going to fail at that point. So you see iteration 4 actually failed out, iteration 5, iteration 6, iteration 7, and 8. All of those actually work, and those are all valid possibilities. And as a designer, you'd have to kind of keep track of these by hand without the optimization option. But what this did is it came back and it said, you know what? Optimally, this is where we want to be. We actually reduced the weight down to 20 pounds. So we took another 6 pounds out of this design. You know, I've heard a lot of times in a couple of companies that I work for, you know, it just looks too weak, even though it works. So you can always switch in between all of these iterations and kind of pick out one that maybe reduces the weight. So this reduced it to 22 pounds, but it still looks a little bit more stout. So the perception of your customer is that it's still strong, even though you know optimal really works. So it's a good bit of the software that allows us to kind of push through with regards to that one. So
the optimization is making use of the parametric data that you already labored to build into the model.
Yeah, that's exactly right. And SOLIDWORKS has always been about reusing, you know, some of that geometry and things that you put into the model. And this is an excellent application of that.
Okay, so you enter the parameters and let simulation do the work behind the scenes calculating the optimal design.
How astute of you, Casey, to recognize that.
Thanks, Robert. It was not rehearsed at all.
Yep.
So we're talking about improving the quality of the products while reducing the cost to make it, which offers immediate value to not only your company, but also more value to your customers and helps you to be more competitive.
Yep, that's exactly right. So we went from 26 pounds to 20 pounds. And if you think about that, that's 6 additional pounds. We really took 16 out of it. And what that does for us is that 16 pounds per one of these that we don't have to ship. That's 16 pounds of raw material we don't have to pay for. So there's huge cost savings in the optimization portion of it. The next section, I just want to talk a little bit about the nonlinear and the linear dynamic aspects of simulation premium. So with simulation premium, one of the big ones is plasticity. So how do we know when we go beyond yield what's going to happen to the design? And then also nonlinear materials. So I'm going to go ahead and close this model and we'll open up this handle. So the first handle that we're going to look at is an aluminum material. It has a load that is put on this, so 180 pounds pushing downwards on it. It's held, and I'm actually using symmetry, which is similar to a roller slider constraint, and what that does is it just keeps this face that's highlighted from moving in and out of plane. This was meshed and then ran. The only difference with this is because we're in a nonlinear analysis. Let me kind of show you where that's at. That's this guy right here. And we can do a nonlinear static or nonlinear dynamic, so whether it's constant load or time dependent. And in this case, if we look, I applied a force, which is the 180 pounds, so linearly applied the force, and then I took the force off. So I purposely pushed this beyond yield to see, and then took the force off to see where would this end up after the force was removed. So if we animate this here, you can see that the stress is starting to build in that lower kind of elbow there. You're actually going to see it go beyond red into a gray, and that's indicating that that's yielding. That's going beyond the yield strength of the material for this specific application. Then the force is now being taken off or reduced, and what you're going to see is it's going to show some residual stress in the analysis. We can actually step through that if we go into our definition here. So this is at 1 second, so the force has fully been removed, and this is how much stress is being, or latent stress is in the design. And one of the things we can look at here is we could go in with like a probe tool and take a look at the result. We have a lot of different options. So if I come in here with my probe, I can actually pick up different locations and say, okay, this is that residual stress at those locations. I could do on selected entities. I could pick this whole face and get an average, a min, a max, an RMS value. We can also chart this, as well as, let's say we want to do this location here. So we're going to pick up this point. So this is the stress at that location over time. So it's really giving us a good amount of feedback of what's happening, and we can see, you know, that residual stress is hanging on in the product. We could also then take this back into the fatigue module, because everything in professional comes in premium, and run a fatigue analysis on this to see how long is it going to last after we permanently deform the geometry. The other thing that I did here is I actually switched to a nonlinear material. So from aluminum, I switched to nylon. And one of the things with this that you have access to or need to give the software is a stress strain curve. So how does this behave beyond yield? So this is a nylon material. It's very soft compared to the other material of the other study. And what I'm going to do here is just kind of animate this for you. So this is the deformation. This is the permanent deformation after that 180 pounds has been put on. So you can see how going from more of a linear material beyond yield to a nonlinear material in the full stress strain curve, this is behaving drastically different. And if we animate this just real quickly, we're going to see that the stress develops and it actually builds really, really fast and really quickly in this area. And you see it's over a larger portion as well. And that's just due to the material properties being changed. And obviously the displacement's drastically larger as well. So we can see that building that stresses over that whole area rather than just those couple of pockets like before. So we can see the residual stress in that deformed shape. We can see stress beyond yield for linear materials and nonlinear materials. And I wanted to also show you another option in SOLIDWORKS Premium, which is a time-dependent analysis where I'm actually doing a large displacement. So we're pushing this tab in by 7.3 millimeters, and it's going to snap over the top of this latch. So this is another good example of where nonlinear analysis comes into play. So this would be similar to maybe even doing like a crush test where it would be time-dependent loading, and you're actually displacing the top of like maybe a cup or a can down to compress it. So if we see, this is actually where the latch is at the tangency point. We can see that the stress is developed pretty high in the back end of this. If I animate this, what you're going to see with it is the stress starts to develop as that engages that center pin. It kind of stays developed, and then as it snaps back over the pin, what it's going to do is it actually reduces the stress as it comes back down. So we can actually see the residual stress of this latch mechanism as it moves all the way through. And again, this could then be added as a repeated load to see how long is this going to last. But we also gain feedback as far as displacement, stress, strain, all of those things, same things that you saw in the linear portion of the package. So what did we really see? We really saw that we could do unlimited initial design iterations. You can do multiple. It's really whatever you desire.
So that really gives the designer the freedom to focus on design innovation rather than worrying if the design is going to pass or fail.
No, that's exactly right. And it also gives you confidence in your design, right? It gives you insight into what's happening. And the other thing is it really gives you the ability to identify and correct errors early in the design process, predict the reliability of your design, reduce prototypes, reduce cost, and ultimately get it right the first time.
So SolidWorks is promoting simulation in June, which is why we did time this webinar, and we have had a lot of customers requesting information on the promotions, but also they wanted to know what package would best suit their needs. So that was the purpose of this webinar. The first promotion that's available through SolidWorks is on Simulation Standard. I've listed the modules on these slides, but certainly if anyone would like us to email this information over to you and go into further detail about what is included in each package, we can do that. The regular pricing for Simulation Standard is $4,000 for the package and $1,000 for the maintenance. So right now in June, if you add Simulation Standard to any existing SolidWorks license that's on subscription, you can add Simulation Standard with the first year of subscription for only $2,000. If you purchase any license of SolidWorks this month at regular price, you can add Simulation Standard for $2,000. So the savings is $3,000 in June. The next promotion is for SolidWorks Premium. So SolidWorks Premium has static linear analysis for parts and assemblies and simulation motion, which Robert covered, included in the package. It is also our highest level CAD package, so I did want to list the modules that are included for the CAD as well. Again, we could send this on to you if you'd like us to after the presentation, just request it. The regular pricing for this is $8,000 for the software and $2,000 for the annual maintenance. It is half off in June for the software, so it's a total of a $4,000 savings. The next promotion is for SolidWorks Premium, so the CAD package that we just listed, so all the functionality you just saw in Premium, along with Simulation Professional. The total for this package is normally $19,000 for the licenses and subscriptions. SolidWorks is offering a bundled package for June for $8,990, so that's a $10,000 savings. So they really are promoting simulation in June, putting together these bundled packages to make it easier than ever to move forward with simulation.
Yeah, that's crazy pricing.
And then the final promotion is for SolidWorks Premium, again, the CAD package, along with Simulation Premium, the nonlinear analysis. So that includes everything you saw in SolidWorks Premium, everything you saw in Simulation Professional, and the nonlinear analysis tools that Robert covered. This package normally for both the licenses is $24,000 for both, including subscription, and for June, SolidWorks is offering it for about $12,000. So that's a $12,500 savings. That pretty much covers the promotions that are available, but again, if you need any other information on these, I can send this over. This is the contact information for myself and your local account manager. If you don't see the account manager listed, or if you don't know who your account manager is, feel free to reach out to any one of us, and we would be happy to help you.